Find polar representation of the point -1, 1, which is a point in rectangular coordinate system, one with positive radial coordinate and the other one with negative radial coordinate. Observe that this point P is in the second quadrant when x is -1 and y equals 1. And we want to find two polar representations that represent this point. One is positive r and another one is negative r. R is the square root of x squared plus y squared, where x is -1 and y is 1. So in this case, r is the square root of 2. To find the polar representation is to find r comma theta. We found r already. To find theta, we use the relationship tangent of theta equals y over x. Tangent of theta is not known at the moment. Y is 1 given, x is -1, so this is -1. Tangent of theta equals -1, so theta is negative pi over 4. Using arctangent of -1, we'll get negative pi over 4, which is an angle in the fourth quadrant. But we want an angle in the second quadrant, that is where the point P is. To get the point in the second quadrant where tangent is -1, we would use theta equals 3 pi over 4. So the point we're looking for is √2, 3 pi over 4. This is one of the 2 points that we're looking for. To find another point with the negative radial coordinate, first we pretend to go to the point opposite to the point P, which is in the fourth quadrant, and that point has the coordinate square root of 2, negative pi over 4 to make it easy. But remember that we want the negative radial coordinate. When we get to √2, negative pi over 4 going clockwise, we obtain the positive radial coordinate, and if we flip it, we will obtain P, which is what we're looking for. Thus, after we flip it, we will get negative square root of 2, negative pi over 4. This is another point that we're looking for. Polar representation is not unique. As we can see, we found 2 already. If we want the negative radial coordinate and the positive angular coordinate, we can keep negative √2, but we simply add 2 pi to this. If we add 2 pi to this, then we'll end up with 7 pi over 4. This will represent the same point because first we would go to the polar axis √2 units, and then we turn counterclockwise and angle 7 pi over 4, and then we flip it to get the negative radial coordinate to obtain the point P in the second quadrant.